Don't forget to subscribe and ring that bell.
Hurry, hurry. Step right up. Enjoy the ups and downs of the wonderful ride you or we are about to get onto. And we are going to call this roller coaster the Practice 2018 AP Calculus AB examination. Wonderful. We're going to start today with problems 1 through 10. Why not start at the beginning? Section 1, Part A. All right. We don't get a calculator. So what? We are smart. Yes, my friend, I'm including you. We are smart. We're going to do this without a calculator. And even if you wanted to use a calculator, you can't on this section. Not at least not for the first 28 questions on this AP exam, all right? So let's take both of our smart buttocks and start with number 1. Number 1, very basic. Integrate the cosine of 3x dx. Okay, I am going to use u substitution. Some of you might be so familiar with this that you don't have to do u substitution, but I'm going to do u substitution in case anyone struggles with this, all right? So I am going to say this 3x right here. I'm going to say u is 3x. So now I'm integrating the cosine of u because I put u in for 3x. Whenever I do a u substitution, not only do I got to put a u in there, but I got to find the derivative of what my u is. The derivative of 3x is just 3 dx. But keep in mind now, okay, this 3x has gone bye-bye. If you look up to the top left, this 3x is now a u, so it's not here. I don't have a 3 dx. I only have a dx, which means my derivative right here, okay, I want to get the right side that just have a dx. And what I'm going to do is multiply both sides by a third. This cancels, and now I have a third here. All right? So in for my dx now goes 1/3 du. All right? And it should make sense. If I have a u here, I should have a du as my dummy variable. Put the du in the back. And my constant, I always like to put constants out front and deal with them after. Integrating the cosine of u is much more simpler than integrating the cosine of 3x. And that's what we've created for ourselves, the cosine of u. The integration of cosine is sine, still a u. There are no bounds, so I need to put a plus c. And if you forgot that, well, look at all 5 of my answers. They all have plus c anyways. Don't forget our 1/3 out front. The only thing left to do is I need to take my u out, okay, and put my 3x back in. Notice we had 3x and u are the same thing. So I'm going to write this 1/3 sine in back in for my u, I should say, is my 3x plus c. This is my answer. Boom. It's the third choice, option C. It's a good one to start with. Number 2, this is another, just solve for this. No word problem, nothing. I like it. Find the limit as x approaches 0 of 2x to the 6th plus 6x cubed all over 4x to the 5th plus 3x cubed. The problem here is if I put a 0 in for all my x's, okay, you see I'm highlighting these, I end up with 0 over 0. That's no good for me. Okay, I can have a 0 in the top, but not a 0 in the bottom. If I end up with a 0 over 0, I can do something called L'Hopital's rule. I love saying that word, L'Hopital. What that tells me to do is I need to take the derivative of my top separately and keep that as my numerator, and then take the derivative of my bottom separately and keep that as my denominator. Then I try and plug 0 in again. If I end up with 0 over 0 again, I do the same process over and over until I get a number. I'm not going to do L'Hopital's rule. I'm going to do factoring. How come? You'll notice, okay, that these exponents are to the 3rd power, which means in order to get the x's to go away, because if I plug a 0 in for the x, it will turn to 0. So I don't want an x there. I will have to take the derivative 3 times before it works out. And you can do that if that's what you're comfortable with. I am going to go to good old-fashioned factoring. All right? because factoring never goes away. I'm going to factor the top here. And I can take out a 2 and then x. That will leave me x cubed plus, I'm going to take out 2x cubed, sorry. That will leave me x cubed plus 3. All over. Now I'm going to factor the bottom. There is no large number or coefficient in common, GCF, but I can take out x cubed. And that will leave me 4x squared plus 3. Okay? I'm still going to, I still haven't tried to take the limit yet. I still got to throw a 0 in for x. But before I do that, I can now cancel like terms. X cubed and x cubed go bye-bye. Okay? This is going to help us here. Now let's try and throw a 0 in for all of these x's. I have 2 times 0 plus 3, which is 2 times 3, which is 6, over, 0 plus 3, which is just 3. Look how nice that is. If you were to use L'Hopital's rule and take the derivative of the top separately and the bottom separately and try again, throwing the 0 in, you would do it 3 times, and you would still come up with 2. Okay, choice D. Very good, very good. Number 3, we finally have some words here, not just an equation. Number 3 says the function f is defined above, and they give us a nice piecewise function. For what value of k, if any, is f continuous at x equals 2? All right, let's establish something. What value of k? I need to find this. I don't need to find the x. I need to find the k. All right? And if you're doing this and you're trying to go fast, you think that you got to find an x and a k, and you can't do it if you got to find 2 variables. The great thing is, it's got to be continuous at x equals 2. Notice, all right, my piecewise function breaks at 2. Okay, if it's 2 or less, I use this upper function, my x value. If it's greater than 2, okay, I've got to use this lower expression, I should call it. So in order for those 2 to form a continuous, that means if I have a graph here, and here's 2, one graph might look like this. I'll draw in black. The other one might look like this. They got to end up with the same value at 2, okay? Because if they don't, okay, then it's not continuous. They got to have that same value down here at 2, all right? So what I'm going to do is I'm actually going to plug 2 into both the top and bottom. Okay, got to throw an x value of 2 because that's what they're asking us to check. And we need to figure out what value of k will make them equivalent. Okay, will make them have the same output or y value. So I have down here. All right, let's start with the top one. It's x squared, and I'm using parentheses for my variable, minus 3 times x plus 9. And I'm going to throw a 2 in there, all right? 2, 2. I want that to be the same as throwing an x into this bottom function. Keep in mind, I'm not throwing a 2 in for k, but in for that x. So it is k times x plus 1, and they want x to be 2. Okay, so let's simplify this. Let's do the math and see if there's a value of k that makes this work. 4 minus 6 plus 9, that's 7. Okay? And we have 2k plus 1. All right, let's subtract 1 from. Now it's just simple algebra. So 6 equals 2k. And if I divide both of those by 2, my k is 3. So a k value of 3 would make this piecewise function continuous at x equals 2. Right? A k value of 3. And that is choice C. Number 4, if f of x is the cosine cubed of 4x, then f prime of x is. We are just taking the derivative of this function right here. What I tell my students all the time is, any instance you see an exponent in trigonometry written like that, immediately rewrite it. We have the cosine of 4x all cubed. because it is easier to understand that you've got to do the chain rule when you see it like that. Okay? I highly suggest you rewrite it, and then at the end, put the exponent back in next to the trigonomic function, trig function, trigonometry, whatever. I think you understand. Okay? First thing, chain rule means I start with the outside. This inside stays the same. So my 3 comes down. The inside is the cosine of 4x. That does not change. Now I reduce the exponent by 1. There you go. I've done the derivative of my power, my exponent. Okay? Now I need to do the derivative of the inside. So this is its own separate functional times. Again, cosine of 4x, they have an inside and an outside. This is the outside. This is the inside. Okay? Meaning, let me write this off to the side. Sometimes you need to see this. This also needs a chain rule. I take the derivative of this first. The derivative of cosine is negative sign. The inside stays the same. Now I multiply by the derivative of the inside, which is just 4. This whole thing is the derivative of the inside. So it's negative sine of 4x times 4. All right? Now, if this were short answer, what I have here is absolutely 110% correct. Okay? Don't try and reinvent the wheel. However, something else I tell my students is, do not simplify unless you have to. Okay? For multiple choice, they tend to give you a simplified answer, always. So what do? Okay, well, let's look. They take all the numbers. They'll take 3. I shouldn't use the yellow. It's tough to see on some screens. They take the 3 times this 4, and then this negative sign. So I'm going to have a negative 12. 3 times 4 is 12, and I negate it. All right? So they'll probably put a negative 12 out front. And then I have, okay, the bigger exponent is squared, right? So it's going to be the cosine of 4x squared. However, let's bring our exponent back here because we're done. Okay? And then we have, after that, the sine of 4x. Don't worry about the negative sign. Remember, we brought that out front. So this is what your multiple choice answer will look like. Okay? And I only see one answer that has a negative 12 out front. That's choice B. And that, my friends, is the right answer. Number 5. The function f given by f of x equals 2x cubed minus 3x squared minus 12x has a relative minimum at what value of x? All right. Minimum. That means I'm going to look at the first derivative. First of all, I want to find out where that's 0. I want to find what's called a critical point. Once I got this, I'm going to call it CP for critical point. Okay. Once I have this critical point, I find out where that is. If I want a minimum, I want a negative first derivative, my critical point, then I want a positive first derivative. So my slope goes down and up. That's what I'm looking for. Okay? The great thing about this is I don't have to check my endpoints because there's no interval. Okay? This is a cubic function. It goes on forever in both directions. There are no endpoints. Thank you. So I need to find the first derivative of f of x. And I'm just going to do the first derivative here. Basic power rule. 6x squared minus 6x minus 12. Let's set that derivative equal to 0 because now we're going to find the critical point. All right? Well, let's divide both sides by 6. Let's get rid of that 6. So I now have x squared minus x minus 2 equals 0. All right, that's factoring, my friends, never goes away. And I think I said that on problem 2 for this set of problems. Factoring never goes away. Two numbers that multiply to negative 2 that add to negative 1 is x minus 2 and x plus 1. Okay, and if I solve those, I have 2 critical points at x equals 2 and at x equals negative 1. Those are my 2 critical points. So I'm going to put those on a number line, my x values, with my first derivative. Okay? Here is negative 1. Here is 2. Those are my x values. And my first derivative is 0 at both of those. That's why they're called critical points. Okay? Critical points can also be undefined first derivative. But when you just have a polynomial like this without a fraction or square root or whatever, you don't have any undefined values. Okay? We just have zeros for our first derivative. Two critical points. Remember, I want to see where they go from negative to positive around these critical points, okay? Here and here. So let's start picking some values in between and plug them into the first derivative and see if my first derivative gives me a negative or positive value. So let's pick -2. Okay? I'm going to put a -2 into this right here. Okay? A -2 minus 2 gives me a -4. So, okay, when x is -2, we're going to have -4 in that first parenthesis. And a -2 plus 1 is a -1. That will give me a +4. I don't care about the 4. I mainly care that it's positive. So right here, these are positive values. Let's check a number in between -1 and 2. 0 is always a favorite of mine. Let's throw a 0 into both of these parentheses for the first derivative, okay? 0 minus 2 is -2. 0 plus 1 is a +1. That's a -2. Again, I do not care about the 2. I care about the negative. Negative, 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 negative. All right? And last but not least, let's pick a number bigger than 2. How about 3? Okay, yeah, I mean, I want to pick 17,862. Good for you. Pick it. You'll get the same sign, either positive or negative. It don't matter. All right? I'm going to go with something simple and see what happens when I plug a 3 into the parentheses. Okay? Again, we're going into the parentheses here for the first derivative, the factored version. I could, if I wanted to, okay, I could try putting it in this one, the unfactored version. That's fine. I could put it in the purple one here. That's fine as well, as long as it's the first derivative. All right? 3 minus 2 is a +1. 3 plus 1 is a +4. I don't care about the number 4. I care that it's positive, which means positive. So which critical point, okay, which critical point goes from negative when it hits the critical point, then goes to positive? This one right here. See how it goes to negative, it hits the critical point, then goes to positive? Okay, number at -1, okay, it goes positive to negative. I don't want that. X equals 2. That's where I have a minimum. And again, I don't have to check endpoints because this function goes on forever. And my answer is C, the number 2. Number 6, let f be the function given by f of x equals 2x minus 1 to the 5th times x plus 1. Which of the following is the equation for a line tangent to the graph of f at the point where x is 1? Anytime we use the equation of a line, I always suggest my students to use this one. Even if it's written y equals like all the answers. Because then at the end, we could just get the y alone. That's fine. This is a million times easier. Only one time in all the tests that I've taken for calculus have I used y equals mx plus b. And that's because they gave me the y-intercept already. Okay? So we are not going to use this unless we absolutely have to. And again, that has happened once in like the 100 exams I've done. Okay? Y minus y1 equals m times x minus x1. Typically, they either give us the x and the y. Okay? So I need to find an x value, a y value, and then I need to find the slope. The slope is generally the most work in all these problems. All right? Let's start with what they give us. Okay? Find the equation of the line tangent to the graph where x is 1. So I have this value here, x minus, well, 1. That's given. I don't have my slope, and I don't have my y value, which is rare. Sometimes I give you a coordinate, an x and a y. Here they don't. But the beautiful part is I'm going to use this function, for both of my unknowns, for my y and my slope. And let's start. F of x is the same thing as y. So I'm going to throw my x value of 1 into the x values into this equation. I'm not taking the derivative. I just want the y value. Okay, notice I put parentheses where the x is going. X is 1 here. X is 1 here. 1 plus 1 is 2. Okay. 2 times 1 is 2. 2 minus 1 is 1. Okay. And 1 to the power of 5 is still 1. Okay. So if I did this right, my y should equal 2. So now I have the second part out of the 3 that I need. And I say y minus 2. There you go. All I need is my slope. Okay, all I need is my slope, and then I'll get the y alone here. Slope, my friends. Oh, where do I start this? I guess right here. Slope, which is my m value, is the same as derivative. So I'm going to find the derivative of my function and then plug in a 1. Power rule. Chain rule, power rule, product rule. Calculus loves to do multiple rules within one derivative process. Okay, what do I mean by product rule? First times the derivative of the second. Okay, and when I do this, I'm going to have to use the chain rule at some point as well. So it is the first, the blue highlighted one, just as it is, 2x minus 1 to the 5th, times the derivative of the second, which is the green highlight. The derivative of x plus 1 is just 1. First times the derivative of the second, plus the second, just as it is, x plus 1, times the derivative of the first. Power rule, chain rule. The 5 comes down. The inside stays the same. I reduce my exponent by 1, and then I multiply that times the derivative of the inside. The derivative of 2x minus 1 is just 2. This is f prime of x. This is the derivative of x, which is ultimately my m. Okay? I want this at x equals 1. All right? So let's go ahead and figure what this is going to be when I plug a 1 in for all these x's. So I got to plug a 1 in here. Okay? Here. Here. And that's it. Is it really only 3 spots? It really is. Look at us go. All right, so 2 times 1, I did this above, is 2 minus 1. So that's 1 to the power of 5. This is 1. Times 1. 1 times 1 is 1. Plus, okay, 1 plus 1 is 2. All right. All right. 2 times 1 is 2 minus 1. That gives me 1 to the power of 4, which is just 1. 1 times 5 is 5. 5 times 2 is 10. 2 times 10 is 20. 20 plus 1 is 21. And that's your m value. I got to plug that up above here for my m. 21. There you go. Now, notice all my answers. I've pointed this out already. They are all y equals. Big deal. Just do some algebra. Distribute the 21 and add 2. I mean, man, quit crying about it, guys. 21 times x is 21x. 21 times negative 1 is negative 21. Y minus 2 equals. Let's just add 2 to both sides. Y equals 21x minus 19. That is your answer. That is choice B, and we're done with it. Number 7, integrate e raised to the square root of x all over the square root of x. U sub, there ain't no way around it. Okay, first of all, let's rewrite this. Okay, it's the integration. The square root of x, that's the same thing as x to the 1/2. I hope you know that. I'm going to make that substitution. That is e raised to x to the 1/2 times, okay, I have 1 over the square root of x. That would also be x to the 1/2. All right. And I have a dx here. I'm going to rewrite it one more time. All right. I am going to bring this x up, and I'm going to negate the exponent. The integration of e to the x to the 1/2 times x to the negative 1/2 dx. I've gotten rid of the square roots, and I've brought in exponents, which is good for derivatives and integrals. I've gotten rid of the fraction. I need to use u sub. This would be a million times easier if I was just integrating e to the u. So I'm going to make this my u value. So u is x to the 1/2. The derivative of u, okay, the 1/2 comes down, x, and I subtract 1. 1/2 minus 1 is negative 1/2. And I can't forget the dx, a dummy variable. This is really nice because this has gone bye-bye already. What I have left is this that needs to sub out. That's right here. I just need to get rid of that 1/2. So why don't we multiply both sides by 2? The 2 cancels the 1/2, and I multiply it by 2. That is not an exponent. I'm multiplying it by 2. I just ran out of space on the side of the board, right? So 2 du is going to go in for my x to the negative 1/2 dx. Okay, so in for this, I'm going to put 2 du. Du on the outside, 2 is a constant. I like to put that on the outside. Du inside, 2 outside. The integration of e to the u is so easy because it's still e to the u. Don't forget this 2 plus c because there are no bounds. I cannot leave a u in my answer. If there were bounds, I could put numbers in for that u. But there are no bounds, so I need to put my x variable back in. So what was u equal to? What is this? What should go in there? X to the 1/2. But let's remember that x to the 1/2 is really the same thing as a square root of x. So I can make this x to the 1/2. But really, I'm going to change it back to a square root. That should be my answer. And if I did that right, and I did, and we did, that's choice A. Pretty good. It's a good problem. Number 8. God, I love tables and graphs and charts. Oh my, I love them. The function f is continuous on the closed interval from 0 to 6 and has values given in the table above. A trapezoidal approximation. That tells me I'm using the trapezoid rule for area under the curve, because an integration from 0 to 6 of f of x is the area under the curve from 0 to 6 of f of x, and it's an approximation. That's why we can use the trapezoid rule. It's not exact. Okay, it is found with 3 subintervals of equal length, and they give you the answer. It's 52. What's the value of k? Let me be honest with you here. It is really rare that they have you use a trapezoidal rule, and they put a variable, k, which in case you didn't see it, is right here. Okay, it's in the table. But they did it here for us, so we're going to do it. We're going to do exactly what they ask. All right? So the trapezoidal rule tells me, well, first of all, 3 subintervals. Let's not get ahead of ourselves. 3 subintervals of equal length. Well, if I'm going from 0 to 6, so if I'm going from 0 to 6, that means it's over 6 spaces. I need to divide that into 3 subintervals. Each subinterval has a length of 2. Okay? So, oh, this is nice, from 0 to 2. You know what? They're trapezoids. Let's go. That's my first one. From 2 to 4, that's a width of 2. Okay, that's my next one. And then from 4 to 6, that is also a width of 2. All right, there you go. So those are my 3 trapezoids with a width of 2. Okay, and what the trapezoidal rule tells me is I need to take my, I mean, people say H for height. I call it W for width. It doesn't matter. Just whatever you call it has to go over 2. Okay, I have what I call my bookends here. I have a number here, and I have a number here. They're really Y values. And I add things, but everything in the middle needs to get doubled. Okay? Everything in the middle needs to get doubled. I don't double the bookends. Okay? So I look at all my ends so to speak, of each trapezoid. There's 4, and then there's k. Okay, 4 is a bookend. It's where I start. I don't double that. Plus, k is not a bookend, so I got to double that. Plus, well, the next value is 8. That is not a bookend, so I got to double that. Okay. Then I get to 12. That is a bookend. That's one of the last values. 4 is a beginning value, and 12 is an end value. I do not double. That's why I call them bookends, because they smush like books, everything in between. Okay. Don't forget, I multiply the width, which is 2, over 2. So that's going to be 1. That's going to be nice. Anything times 1 is itself. But here's the extra part. This area should equal 52. I mean, now this is basic algebra. I told you you ain't going to need no stinking calculator. Right? So let's just do the math and figure this bad boy out. 4. Oh, let's do this. This gives me 16. Okay? 16 and 12 is 28. 28 and 4 is 32. Plus, I still have my 2k. Equals 52. Oh, easy. Minus 32 from both sides. 2k equals 20. And divide by 2. Which, I mean, I when I'm in calculus, I don't divide by 2. I say k should be 10. And you should know that. That is very basic. A k value is 10. That is choice D. We're done with number 8. The final 2 problems, number 9 and number 10. Let's go number 9. A particle moves along the x-axis so that at any time t greater than 0, its velocity is given by v of t, which is 4 minus 6t squared. If the particle position, here we go, is 7 at time 1, what is the position of the particle at time 2? So my thought process here is, if we have velocity, okay, and we need position, and I write this a lot, there is position, velocity, and acceleration. These are always one derivative away, okay? But we're going backward, which means we need to integrate velocity to get position. Not only that, we don't have bounds. So we're going to have a plus c. We're going to have something plus c. We need to find out what the c is given an initial condition for position. Once we get that equation, then I need to plug in a 2. So it's a little bit of work here, but, you know, we can do it. So let's integrate velocity, which is 4 minus 6t squared. Don't forget that dummy variable. Okay, let's integrate that. We get 4x. Okay, this will be minus 6t. I increase the exponent, then divide by that, plus c. This is position. We'll call this x of t. Why not p for position? Because they give us an x and a t. So I'm going to use x and t. Quick little simplification. 3 goes into 6, 2. So it's really minus 2t cubed. All right? So they say when x is 7, I'm getting that right here in the problem. Okay, that's at a time of 1. And I use an x here. Shame on me. This should be a t instead of an x, just to keep everything consistent. All right, so that's when t is 1. So we got 4 times 1 minus 2 times 1 cubed plus c. All right, so 7 equals 4 minus 2 plus c. 7 equals 2 plus c. Therefore, c has to be 5. Okay, if I subtract 2 from both sides, c is 5. I've got to put a 5. Here's my equation for position right now. I want to put a 5 in for this c. So let's go down here. This board. I'm getting a new one of these boards, people. I'm going from the smart board to the TV, which will be nice. So you have x of t is 4t minus 2t cubed, and that's plus 5. My c is 5. So once I have this equation, they're asking me Okay, what is the position? So I need to figure out what is this, okay, this x of t, of the particle at time 2, at a t value of 2. I'm going to use this equation, all right? And let's go ahead and do that, and we'll be done. 4 times 2 minus 2 times 2 cubed plus 5. 8, 2 cubed here is 8 times 2, so it's 16 plus 5. So negative 8 plus 5, is that a negative 3? Is that a negative 3? How good are we, children? It is a negative 3. So we're going to come all the way back up here. And my answer, there's been a lot of C's. And the answer to 9 is also C. Number 10, the final question in this video and this set. The function f is given by f of x equals a x squared plus 12 all over x squared plus b. The figure, in this case, bottom right, I moved it, it's not above, shows a portion of the graph of f. Which of the following could be the values of the constants a and b? All right, so let's go ahead and establish. We got to find out a, which would be right here. Okay, and we got to find out our b, which will be right here. All right, and I like this problem because when I look at the graph, I see two asymptotes. Okay, that and L'Hopital. Asymptotes and L'Hopital are two of my favorite words in math, I should say. Okay, I have two asymptotes. I have a vertical asymptote at x equals 2 right here. Then I have a horizontal asymptote at y equals 3 right here. And that's really going to help me figure out what A and B are. All right? And this really tests you on your familiarity with finding a horizontal and vertical asymptote algebraically. And you can use limits or you can just know your rules. Okay? That's what I like about this problem. It's not common, but I like it. All right, so let's go. Let's go with A. All right, let's find A first. Alphabetically, it's naturally first. All right, so in order, okay, to get a horizontal asymptote, all right, in order to get my horizontal asymptote at y equals 3, all right, I need to take the limit as x goes to either positive or negative infinity of my function, ax squared plus 12 over x squared plus b. Now, keep in mind, a and b are constants. In order to plug in infinity into, or take the limit of infinity of any function, I keep the biggest term on the top, which is this, and I keep the biggest term on the bottom. Okay, so I've got ax squared over x squared. This should give me, okay, this limit should give me my horizontal asymptote. All right, so I look at what I have here, simplified. Before I even plug in infinity, I got the biggest term on the top, biggest term on the bottom. Can I cancel anything? Yes, my x squareds cancel. So I just have a. Remember, it should equal 3. So right there, it tells me, in order for my limit of f of x as x approaches infinity, in order for that to equal 3, a has to be 3. So look at, a is negative 3? No, no. A is 2 for choice B? No, no. A is 2? No, no, bye-bye. 3 and 3. So it's either choice D or it's choice E. So let's take a look at B now. Okay, B. Let's find B. All right. Well, we did a horizontal asymptote, and B is in the bottom. It's in the denominator. I'm going to use the vertical asymptote. So my vertical asymptote happens at x equals 2. All right. So in order to have a vertical asymptote, I need to figure out what makes my function undefined. Okay? In order to make a fraction undefined, the bottom of my fraction, okay, has to equal 0. So if I got x squared plus b, and it has to be 0, okay? And x, okay, they say this happens when x is 2. So 2 squared plus b is 0. 4 plus b is 0. So guess what? B has to be negative 4. Because 4 and negative 4 give me 0. That's it. So choice E has a positive 4. Choice D has the negative 4. That is it. We are done. I told you I liked that problem. Y'all didn't believe me, but I did. I told you. Okay, we are done 1 through 10. A lot of explanation. Lot of writing and work through 1 through 10. 40 minutes is a little bit long for a video. For the first 10 problems for me on average, they normally get close to 30 minutes. But that's it. Like, subscribe, ring the bell, comment, follow me, because that's the only way you get notifications of when I put up future videos. Like maybe problems 11 through 20, which will be coming very soon to a carnival or theater near you, my friend. All right, Mr. Smarty Pants or Miss Smarty Pants or Smarty Pants extraordinaires. We'll see you for the next video. Bye-bye.
Don't forget to subscribe and ring that bell.